वेलकम टू वीलन। वीलन में आपका स्वागत है। सब्जेक्ट ऑपरेशन रिसर्च सेशन नंबर 6। टॉपिक टू बी कवर्ड इन दिस सेशन: गोल प्रोग्रामिंग, इंट्रोडक्शन, कॉन्सेप्ट ऑफ गोल प्रोग्रामिंग, गोल प्रोग्रामिंग मॉडल्स फॉर्मुलेशन, गोल प्रोग्रामिंग मॉडल फॉर्मुलेशन, graphical methods of goal programming, the simplex method of goal programming, and application areas of goal programming. And now introduction. Organizational objectives vary according to the characteristics, types, philosophy of management, and particular environment conditions of the organization. There is no single universal goal for all organization. जैसा कि आप जानते हैं कि किसी भी ऑर्गेनाइजेशन का कोई यूनिवर्सल गोल नहीं होता है। सभी ऑर्गेनाइजेशंस के अपने अलग अलग गोल होते हैं और दे आर वेरी कॉम्प्लेक्स टू अचीव। तो प्रॉफिट मैक्सिमाइजेशन विच इज रिगार्डेड एज द सोल ऑब्जेक्टिव ऑफ द बिजनेस फर्म इन क्लासिकल इकोनॉमिक्स थ्योरी इज वन ऑफ द मोस्ट वाइडली एक्सेप्टेड गोल्स ऑफ मैनेजमेंट। इन टूडेज डायनेमिक बिजनेस इन्वायरमेंट, profit maximization is not the only objective of management. And now, concept of goal programming. Linear programming technique that has been applied quite extensively to various decision problems has a limited value for problems involving multiple goals. The difficulty in using linear programming lies in the undimensionality of the objective functions, which require maximization or minimization of one objective functions and oversimplification of reality. However, in real life situations, multiple goals and sub-goals must be taken into accounts. In goal programming, the objective functions contains primarily the deviational variables that represents each goal or sub-goal. The objective functions become the minimization of these deviations based on the relative importance or priority assigned to them. The solution of linear programming is limited by quantification. Unless the management can accurately quantify the relationship of the variables in cardinal numbers, the solution is only as good as the inputs. It is important to consider formulation of the model before getting into the details of goal programming solution. In fact, the most difficult problems in the application of management science to decision analysis is the formulation of the model for the practical problems in the questions. In order to provide some experience and insight into formulating and analyzing a goal programming problems. Example, a textiles company produces two types of materials A and material B. The material A is produced according to direct orders from furniture manufacturers. The material B is distributed to retail fabrics stores. The average production rates for the material A and B are identical at 1000 meters per hour. By running two shifts, the operational capacity of the plant is 80 hours per week. Example 2. The marketing department reports that the maximum estimated sales for the following week is 70,000 meters of material A and 45,000 meters of material B. According to the accounting department, the profits from a meter of material A is rupees 2.50 and from a meter of material B is rupees 1.50. The management of the company decides that a stable employment level is a primary goal for the firm. Therefore, whenever there is demand exceeding normal production capacity, the management simply expands production capacity by providing overtime. However, management feels that overtime operations of the plant of more than 10 hours per week should be avoided because of the accelerating cost. The management has the following goals in the order of importance. Goal programming model formulation. The first goal is to avoid any underutilization of production capacity, that is to maintain stable employment at normal capacity. Second, the second goal is to limit the overtime operations of the plant to 10 hours. 3. The third goal is to achieve the sales goals of 70,000 meters of material A and 45,000 meters of material B. The last goal is to minimize the overtime operations of the plant as much as possible. Formulate this as a goal programming problems to help the management for the best decision. Goal programming model formulation, production capacity. The production capacity is limited to 80 hours at present by running 2 shifts. However, since overtime of the plant is allowed to a certain extent, the constant may be written as x1 plus x2 plus d1 bar or minus d1 plus equal to 80, where x1 equal to number of hours used for producing material A, x2 number of hours used for producing material B, d1 minus underutilization of production capacity as set at 80 hours of operation, and d1 plus overutilization of normal production capacity beyond 80 hours. Now goal programming model formulation 3. Sales constraints. In this case, the maximum sales for material A and material B are set at 70,000, 60 and 45,000 meters respectively. Hence it is assumed that overachievements of sales beyond the maximum limits are impossible. Then the sales constraint will be as before. K and x2 are expressed in 1000. So x1 plus d2 minus equal to 70 and x2 plus d3 minus equal to 45, where d2 minus equal to underachievement of sales goal of material A and d3 minus equal to underachievement of sales goal of material B. Overtime operation constraint. To solve the problems by goal programming, we need a deviational variable that represents the overtime operations of the plant beyond 10 hours. The overtime operations of the plant D1 positive should be limited to 10 hours or less. However, it may not be possible to limit the overtime operations to 10 hours or less in order to meet higher order goals. Therefore, D plus can be smaller than, equal to or even greater than 10 hours by introducing some new deviational variables. A constraint regarding overtime can be expressed as D plus 1 plus D minus 1 2 minus D plus 1 2 equal to 10, where D minus 1 2 equal to negative deviation of overtime operations from 10 hours and D plus 1 2 equal to overtime operation beyond 10 hours. It is appropriate to assign these as different weights in goal 3. The differential weights imply that management is relatively more concerned with the achievement of the sales goal for material A than that for material B. Now the model can be formulated as minimize Z equal to P1 D1 minus plus P2 D4 plus 5P3 D2 minus plus 3P3 D3 minus plus P4 D1 plus, subject to x1 plus x2 plus d1 minus d1 plus equal to 80, then x1 plus d2 minus equal to 70, then x2 plus d3 minus equal to 45, then d1 plus d12 minus d12 plus equal to 10, x1 x2 d1 minus d2 minus d3 minus d1 plus d12 minus and d12 plus greater than equal to 0. Step 4 goal programming models formulation. The steps we have taken in the model formulation can be briefly summarized as follows. Number 1, define variables and constants. Number 2, formulate constraints. And number 3, develop the objective function. Now graphical methods for goal programming. The deviation from the goal with the highest priority is minimized to the fullest extent possible before deviation from the next goal is minimized. The graphical method is illustrated with the help of the following example. The best way to explain the simplex method of goal programming is through an example. So let us take example 2 under goal programming model formulation. Minimize Z equal to P1 D1 plus P2 D4 plus 5P3 D2 plus 3P3 D3 plus P4 D1. subject to x1 plus x2 plus d1 minus d2 or minus d1 plus equal to 80, x1 plus d2 bar minus equal to 70, x2 plus d3 bar equal to 45, d1 plus d2 d12 minus d12 plus equal to 10, where x1 x2 d1 bar d2 bar d3 bar and d1 plus d12 bar d12 plus greater than equal to 0. First, in goal programming, the purpose is to minimize the unattained portions of goal as much as possible. This is achieved by minimizing the devotional variables through the use of certain preemptive priority factors and differential weights. Second, it should be remembered that preemptive priority factors are ordinal weights and they are not commensurable. Consequently, Zj or Zj minus Cj cannot be expressed by a single row as in linear programming. Third, since the simplex criterion Zj minus Cj is expressed as a matrix rather than a row, a new procedure must be devised for identifying the key column. Again, since Pj greater than Pj plus 1, the selection procedures of the column must be initiated from Pj and move gradually to the lower priority levels. Now this one, the solution to the problems by simplex method, like this is given as Cj and then so on. A goal programming model performs three types of analysis. Number one, it determines the input requirement to achieve a set of goals. Number two, it determines the degree of attainment of defined goals with given resources. Number three, it provides the optimum solution under the varying inputs and goal structures. The goal programming approach to be taken should be carefully examined by the decision makers before he employs the techniques. And now, do it yourself. Question number 1, explain the following terms. Number 1, deviational variables. Number 2, preemptive priority structure. Number 3, differential weights. Number 4, cardinal value and ordinal value. And question number 2, what is goal programming? State clearly its assumption. And that's it from session number 6. Thank you.